Hi, scientists. All right, well, hey, if you're like most people, you are wondering, hey, when is this whole COVID-19 sheltering in place thing going to end? So, we're going to talk a little bit about that today. We're going to be talking about viruses, how you get immunity to them, and how vaccines play a role in that. So, when is life going to get back to normal? When are we going to get to go to rallies at school and be in the same room with each other and hang out again? Um, so a big part of that is people getting immunity to COVID-19. So when you have immunity to a disease, it means it can no longer make someone sick. So when people are immune, the disease cannot make them sick anymore. Public health people think that we can get back to normal when we have this thing called herd immunity. And what that means, what herd immunity is when most of a population is immune. It means they cannot get sick. They're immune to an infectious disease. And this provides indirect protection or herd immunity to those who are not immune to the disease. So in simpler terms, it just means when enough people in the community are immune to the disease when it can no longer make them sick, then the disease can't spread as easily. Okay, so herd immunity, it's not just for sheep. So let me give you some examples. Measles, mumps, polio, and chickenpox are examples of infectious diseases that were once very common but are now rare in the United States. Most people in the United States are immune from these diseases. So even if a population is exposed to the disease, it's going to have a hard time spreading because most of us are not going to get sick from it. If we can't get sick from it, then we can't spread it. So here's a picture that kind of illustrates that. In this top left picture, you have this one person. They have immunity to the disease because they have antibodies, and we're going to talk about what that means in a minute. This pink person is contagious. All of these blue people are lighter blue people. They're healthy, but they're not immune. They don't have antibodies. This pink person then can rapidly infect all of these people. Okay, because there's no herd immunity. Once you have herd immunity, you can see when most people have the antibodies in this dark blue, there's still a few that don't. The disease has a hard time spreading to those few people. Some will still get sick. But since most of the population is immune, the virus can no longer spread. So that's what we're trying to do with COVID. So how do we get to this point? How do we get to this spot where we have most of the people immune? That's what we're going to talk about. So one way to get immunity, well, there's two ways. One way is you get the disease itself. And we're going to talk about what that means when you get the disease and how that gives you immunity. The second way you can become immune to a disease is that you can get vaccinated against it. Okay, so those are the two ways. So let's talk about the first way. To get immunity is through natural immunity, aka people just get the disease. When your body has been exposed to a virus, your immune system, that's the part of your body that fights infection, they create these things called antibodies. And we talked about these at the beginning of the year. These antibodies are very specific to the type of virus that infects them. The antibodies attach to the virus, so let's just pretend this was COVID-19. The antibodies, your body will make antibodies specific just to that virus, and they attach onto them. And that signals your immune system to come in and destroy it. Now, this can take a few days to a week. So while the antibodies are attaching to the virus, first your body has to make the antibodies. That can take a few days. In the meantime, these viruses are going around making you sick. But after a while, these antibodies then catch up, they start attaching to the virus, and then your immune system comes in and destroys all the viruses, and then you get better. And so, but that can take a little while, and usually people end up being sick while they're waiting for those antibodies to kick in. So what happens here, which is kind of cool, is that after you're done with the disease, your body will actually keep copies of the antibodies around for a while. It depends on the disease, how long it how long your body keeps them around, but it'll keep them around for a while. So if you're ever exposed to the virus again, it's ready with those antibodies. You don't have to remake them all from scratch. So here's like a little guy shooting the little antibodies at the virus because he's got them all ready to go. So that's one way you get immunity to a disease. For certain diseases have antibodies means you're immune to them, and how long that immunity lasts kind of depends on the virus. For example, antibodies for diseases like the common cold, those last for about a year. So if you get a cold, you probably will have antibodies to that particular cold for about a year. Whereas antibodies that protect against like the chickenpox, those last you for a lifetime. So once you've been exposed to the chickenpox once, you'll never get it again. Because COVID-19 is new, scientists aren't really sure if or how long people who have been exposed to it and recover will have immunity. They have shown that people have created antibodies. They're just not sure if those antibodies are enough to keep people from getting reinfected, or if they do keep people from getting reinfected, how long they last. People think, based on what they've learned about other types of coronaviruses like SARS and MERS, they think that people who get sick from COVID-19 will have immunity for about 1 year. They're not 100% sure of that, but that's what they think so far. So the downside to everyone getting sick is that a lot of people would have to get sick, and this could overwhelm our hospitals. The downside of getting herd immunity through everyone getting sick is that everyone might get sick all at one time, and we might not be able to take care of them all. So for example, they were really worried in New York that a lot of people were going to get sick from COVID-19 at the same time, which is what happened. And they actually converted a convention center in New York into a makeshift hospital because so many people were getting sick at the same time. Okay, so that's one of the dangers of just letting everybody get it. So there is a second way to gain immunity, and that is through vaccination. A vaccine is a small amount of the killed or the weakened virus, and people are given it so their bodies can produce the antibodies, those things that are going to attach onto the virus, without actually getting sick, without actually contracting the disease itself. Okay, and again, it's a weakened virus or it's a killed virus. So the antibody cannot make, or the vaccine can't make you sick, but it tricks your body into making antibodies against the disease. So you might be asking, well, why don't we just vaccinate everyone against COVID-19? That would solve this problem. Well, the virus that causes COVID-19 is so new that we haven't developed a vaccine to prevent it yet. And vaccines can take quite a long time to develop. Scientists think it will be about 18 months to create a vaccine that protects against COVID-19. And although that might seem like a long time, this would be the fastest scientists have ever created a new vaccine. The fastest they've done it in the past has been around 5 years. So they are working on that now. There are actually 3 phases of making a vaccine. Phase 1 is when they develop it in the lab and they give it to a small group of people. They receive this trial or test for the vaccine. So for example, scientists have a vaccine they're hoping is going to work against COVID-19, and they began testing that vaccine on 45 healthy people up in Seattle in March. So they've begun that phase 1 for, I think they're in phase 1 for quite a few different vaccines at this point. So they just want to make sure, see how a few people react to it. So then after, if they have a few people and they find out that, oh, no one's getting really sick or there's nothing horrible happening to these people, then the vaccine is given to people who have characteristics that are similar to those for whom the new vaccine is intended. So for example, we know COVID-19 affects older people a lot more than younger people. And so we would want to, in phase 2, we want to test this vaccine on older people and make sure it's not causing them to get more sick. And that seems to be working. So phase 2 includes about 600 people. So then when they're done with phase 2, that's when this vaccine is given to like hundreds of thousands of people. And this is when they're really testing to make sure the vaccine works, that it can actually keep people from getting the virus, and that it's safe, and make a whole bunch and then realize, hey, this vaccine doesn't even work. so that before they invest all that time and energy into it, they want to make sure the vaccine works and, of course, that it's safe. So that is why it takes this much time. You don't want to make people more sick. So that's why they test it on small groups of people first, and then they start testing it on larger groups. And again, you want to make sure it's effective. You need to make sure the vaccine will actually work on most people before they put effort into making large quantities of it. So that's it for my presentation. Now what I want you to do is go on to Discovery Education and complete the Viruses, Vaccine, and Immunity Board. And that's going to kind of review some of the information I just talked about. There's some videos in there and some things I'd like you to read. When you are done with that, please complete the Virus, Immunity, and Vaccines worksheet in Google Classroom. When you're on your Discovery Ed board, you can take notes that you'll use. When you're on this board here, you'll take notes that you're going to use to answer the questions on this worksheet. And please, you guys have been getting pretty good at this. When you're done with the board and you're done with your worksheet, please hit the Mark as Done button in Google Classroom. That lets me know that you have turned it in and you're ready for me to look at it. That's sort of signal to me to look at your work. Okay, I hope this was interesting. I hope you learn a lot about vaccines and immunization. And if you have any questions, please ask. All right, thanks, kiddos.